Hello everyone, welcome to another mathematical online lesson. Our lesson for today is radical expression and equation. Now, when you hear the word radical, what comes in our mind usually is the radical sign or the square root sign, as they say. So this is the radical sign. So say for example, we have here the cube root of 8. 8 here stands as the radical, while 3 is called the index. Now this one is in the radical form. We can also rewrite this one in exponential form. The cube root of 8 in exponential form is written as 8 raised to the power 1 third. Now notice here the index becomes the denominator of the exponent, while the power or the exponent of the radical, which is 1, becomes the numerator of the exponent on the exponential form. Again, the exponential form of the cube root of 8 is 8 raised to the power 1 third. The radicand 8 becomes the base in the exponential form. The index here becomes the denominator of the exponent of 8, while the power here on the radicand becomes the numerator here in our exponential form. Now to give you a clear view of this one, let's have an example. Say we need to transform the radical form or the exponential form, or vice versa. So I have here square root of 48. Now square root, when we say square root, here we have an imaginary index of 2. So here, the index for square root is 2. Now, to transform this one into exponential form, so let's just copy the radicand. Again, the radicand becomes the base. So, in a radical form, the exponent here will always be a fraction. Now, the power of our radicand here is 1, so the numerator of our exponent here is 1 over its index. So this is the exponential form of the square root of 48. Again, here, square root of 72. Copy the radicand. Your radicand becomes a base. Square root has an index of 2. 72 here has an exponent of 1, so the exponent here is 1 over. Now here we have the cube root of 64. Copy the radicand. Your radicand becomes the base. Since the exponent of your radicand is 1, so you have 1 over the index. Okay. Now what if it's the other way around? Transforming the exponential form into a radical form. So again, we all know that the base is the radicand. The denominator of the exponent is the index. The numerator of the exponent is the power of the base. So writing this one is, since this is 3, so it's a cube. Copy the base becomes your radicand, and then the exponent Simplifying this one using the law of exponents, distributing the power would give you the same answer as 2x. Next, this one. The quantity 7x being raised to the power 2 thirds. Again, the denominator of your exponent is your index. The numerator of your exponent is the power of your base. So since 3 is the denominator, so this is a cube. Your base becomes your radical. The numerator of your exponent becomes the power of your radical. Now simplifying this one using the law of exponent, distribute that one here. So this becomes the cube root of 7 raised to the power 2 is 7 times 7, which is 49. X raised to the power 2 is x. So this will be our x. Lastly, you have the quantity 2y being raised to the power 5 over 4. So here, the denominator of the exponent is 4, therefore this is the fourth root. The base becomes our radical. The numerator of the exponent becomes the power of our radical. Simplifying this one, so following the law of exponent, you need to distribute the exponent here. So 2 raised to the power 5, that's 2 times 2 times 2 times 2, which is 32. Y raised to the power 5 is y raised to the power. This will be the transform form of our exponential form. Now next is, how do we simplify a radical? Simplifying radical is the same as simplifying an improper fraction. So say for example, you have here 9 over 4. This is an improper fraction. Then you need to simplify this one, right? Simplifying this one gives us a mixed fraction, which is 2 and 1/4. So it's the same concept as this one. Simplifying radical. It's the same as simplifying fraction. Now, how do we simplify a radical? So say for example here, I have the square root of 48. Now, the easiest way to simplify this one is by factoring the radical by 2. If the radical is an even number. So let's just try to divide this one by 2 until such time that all the numbers left are prime numbers. So let's have it here. So 48 divided by 2 would give you 24. This one is prime number, so let's proceed dividing this one by 2 again, since this is an even number. The purpose of this one is that make sure that all the numbers left are prime numbers. Okay? So 24 divided by 2 gives you 12. Again, 12 divided by 2 gives you 6. 6 can still be divided by 2, gives you 3. Now here, all the numbers here are already prime numbers. 2 and 3 are prime numbers. So the next step is, since this is a square root, which has an index of 2, so we need to pair same numbers by 2. So we need to pair this one here, we need to pair this one here. Notice that we have one number left here. So the next step is, the value of this pair is 2, since they are of 2. value of this one also is 2. Then the next step is you need to multiply the value here. So you have 2 times 2 gives you 4. Then this one, since it has no pair, so you need to put it back under the radical. So this is the simplest form of the square root of 28. Again, another example here, the square root of 72. So since this is an even number, this is divisible by 2. So let's try dividing by 2. 72 divided by 2 is, this is 36. 36 divided by 2 is 18. Right? 18 divided by 2, that is 9. Now 9 here cannot be divided by 2, but this can be divided by 3. 3 divided by 9 gives us 3. Now here, all the numbers left are prime numbers. So we can start pairing the numbers. Since this is the square root, it has an index of 2, so let's pair 2 same numbers. So here, this one here does not have any other pair, but we also have another pair here, which is 3. Now the next step, find the value of the pair. So this is 2. Since this is 3 and 3, so the value of this one is 3. Then multiply. 2 times 3, that's 2 times 3 is equal to 6. And since 2 here does not have any pairs, so let's put it back into the radical. So the simplest form of the square root of 72 is 6 square root of 2. Now let's try to have it here. This is the cube root of 92. Again, this is an even number, so let's try to divide it 1 by 2. 92 divided by 2 gives us 46. Right? That's 12 is 92. Okay. Next, 46 divided by 2, this is 23. Now notice here, 23 is an even number. Though it's a big number, but it's a prime number already. So the factors for this one is only 23 and 1. So we cannot divide it 1 by 2, we cannot divide it 1 by 3. Now, the index here is 3. So we need 3 same number. Now, since we do not have 3 the same number, so the cube root of 92 is already on its simplest form. Okay, so we cannot simplify this one anymore. This is already on its simplest form. So I'll give you another example here. Say for example, I have here a cube root of 8. Okay, so since 8 is an even number, let's try to divide by 2. 8 divided by 2 is 4. Right? 4 divided by 2 is 2. Now here, we have, since the index is 3, we need 3 same numbers, which is 1, 2, 3. So we have 3 pairs here. And then the value of this one is 2. Therefore, the simplest form of the cube root of 8 is 2. There. Now, I want you to take a look at this one and observe. Go ahead, pause the video, and try to study the behavior or the relationship between the power and the root. The root. So here on the first part, x raised to the power 6 being raised to the power 2, following the law of exponents, so you need to multiply the here, the fifth root, this is the index is the same number being raised here. So the fifth root of this one is the base here, and so on. Okay, so I want you to study this one. You may pause the video and try to observe the relationship between the exponent and the index. So what's the base and the radical? Now let's go ahead and proceed to the example. So here, I have here the square root of z raised to the power 8. Now, since this is a square root, it has an index of 2. So how do we simplify this? So based on this one, the simplest explanation for this one is the exponent here on the variable being divided by the index. That is the simplest explanation on how to get or how to simplify variables with exponents. Okay? So here, the square root of z raised to the power 8 is simply z raised to the power 4. So it's the exponent divided by the index. Now the next example here is the cube root of 8y raised to the power 12. Now notice here that we already have a numerical coefficient inside the radical. So let's process this one term by term. Okay? So let's process here first the 8. Following the previous example that we have, simplifying this one is simply dividing it by 2. So you have 8. Since 8 is an even number, so we can divide it by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. So we have 3 pairs of 2 here. Since that is a cube root, we need 3 pairs. So the value here is 2. So we can just write here as 2. Now, the variable now, so again, the simplest way is to divide the exponent by the index. So 12 divided by 3, so you have y raised to the power 4. There. That is the simplest form of the cube root of 8y raised to the power 4. Another example here, you have the cube root of negative 64x raised to the power 9, y raised to the power 24. Again, process the numerical coefficient first. Since this is negative, let's disregard first the negative sign. Okay? Anyway, we can just copy this one again. So we have here divided by 2. 64 divided by 2 will give you 30. 32 divided by 2 will give you 16. Right? 16 divided by 2 gives you 8. 8 divided by 2 gives you 4. 4 divided by 2 gives you 2. So all the numbers left are prime numbers now. So since this is cube root, we need 3 sets of the same number. Okay. So the value of this first set is 2. The value of this second set is also 2. Then multiplying this one, so you have 2 times 2 gives you 4. Now, since this is a negative, just copy the negative sign there. Now, going to the variables, x, the exponent is 9, so divide 9 by 3, so you have 3. Next is y, 24 divided by 3 gives you 6. This is the simplest form of the cube root of negative 64, x raised to the power 9, y raised to the power 24. So I hope you learned something today, and